Here's how you get started with MATLAB. Fire up a web browser, go to citrix.ensum.edu, log in with the same username and password you used to log into your email account. Find the MATLAB application. Be careful that you go from MATLAB. Some of you might have Mathematica as a possible application as well. So go to MATLAB. Single click will do. As you do that, look up here. If it doesn't seem to be working, it might be blocked on your computer and you have to unblock it. I had to, first time I tried it with this particular browser, which is Firefox, I clicked unblock and remember, so it would stop blocking it from then on. And if you use Internet Explorer, I know when you click on the application, it downloads something that you actually have to click on and run in order to get here. It automatically runs when you're using the Firefox browser. So it's getting started now. Be aware that it can be very slow. It's taken quite a while on my computer, so you might have to be patient with it. But MATLAB is fired up and running at this point, and we're at in the command window. As you can see, it says command window right up there, and you can try stuff out here, like type in some mathematical expression and make sure that it's working. But you're going to be writing your programs using the editor. So I think the first thing I want to do is go to the place where I want to save my programs. I think I'll put them in temp this time, since I don't really need any of them. I'm just going to be doing some practice, just making up some code to show you. So click Edit to fire up the editor for writing an actual MATLAB function. And every function begins with a function statement, which starts with the word function. Function. And I think I'll write a little program that calculates the square of a number. So somebody enters a value when they go to use this function, and it returns the square of that value. So I'll call it square of argument equals square, and I'll go back to the command window just to make sure. I want to call my function square, and I want to make sure that's not already a keyword. It's not already a function that's defined inside of MATLAB. And I say nope, doesn't use square, so I'm okay to use it myself. And let's see, I want to get the editor back up there. Square of argument is equal to square, and it's going to take one argument, and I'm going to call the name of the argument end, or square. I was thinking about what I wanted to type down here. You got to type in end for ending the function, and then got space over 1, 2, 3, 4. 3 will do it. And then comes the body of my program, the body of the function, what it does. And this one only has one step. The last line has got to be an assignment statement that assigns the answer to your return variable. So this thing, square of the argument, is the return variable. I named it square of argument. The function statement has 4 elements, I'll call it. The word function, the return variable, the equal sign, the name of the function, and then within parentheses, the argument list. I think we're up to 5 elements. So then the body, in my case, the whole body of the function has only one line. It's an assignment statement, and it assigns the value of x squared to square of the argument. I'm going to put a semicolon at the end there. If I don't, then while the function is running, it prints out whatever gets evaluated there, and I don't want that extra printout. So now I have to save this. Click on this little icon for save. I could go File, Save if I wanted to. And I'm working in temp, so I'm going to call it there, and it's called square.m. I save it. Now I go back to the command window and try running it. So to run it, I type in, oh, by the way, let's look at what I saved that as. File, save as, and it was square.m. So the name of the function, there it is right there, square.m. What you save it as has to be the name of the function and then .m. So it's a .m file. Alright, let's get back to here. Now to run it, I type in the name of the function and then the value that I want the function to operate on. So I'm going to try a 5 here, square of 5. If things are working right, it should tell me that the answer is 25. Clearly things are not working right. I'm going to go pwd print working directory, and it says I'm in H. I thought I had switched to temp. Let's try double clicking on temp. And then I'm going to go up there. There we go. So I was able to switch it from up there. The double clicking didn't seem to work for me. PWD, and I'm in temp, and try it again. I can hit the up arrow. That's what I'm going to do. The up arrow makes it so that what's on the command line is my most recent command. I hit it again, and I get the square of 5. That's what I wanted. So rather than type that in again, I just hit the up arrow on my keyboard, and then enter, and it says the answer is 25. Test it out with one more. Expecting it to come out to be 4. Square root of 2 is 4, and there we go. Go ahead and write that program and run it. You will have created your first MATLAB function. Let's do. I'm going to do one more. This has to do with your one of the things you have to do. Oh, wait a second. I found when I wrote the program the first time, my first attempt at it for your project number 1, I used a while loop. So let me tell you about that. So I'll go function. I'll go no return variable. I'll just call it no return. The shorter the better. So in other words, I'm not using this. So I just made up some name telling the user that I'm not using it. I usually use dummy, so a dummy variable is just a placeholder. But you need something here, even if you're not going to return anything. I'll call it count up. I'm pretty sure that's not used, so I'm not going to worry about going to the command level and making sure there's no such thing as count up. Maybe I'll go count up 2, and I'll call it the argument end. And I go and end here. So this is really just to demonstrate a while loop. And I'm going to create a while loop. We have while something is going on, do something, and then end. So this editor does some automatic indentation to make things look good. So while what? I'll go while I is less than n. I think I'll say I is equal to 1. Let's try that. Tab over. Oh. I equals 1. So my idea here is somebody, the user, plugs in a value of n, and the program lists all the numbers from 1 to n. So the user is supposed to put an integer in there, and I'm going to say disp. That makes it be printed, displayed to the screen, or printed to the screen. I usually call it printed to the screen. Disp I. So display the value of I, and then assign to the value of I plus 1. I just put spaces in here. You don't really need them. And then semicolon, so the i's don't get printed out more than once. And here's the way this while loop works. I suppose somebody types in the number 5 there. N is equal to 5. The user types in count up to 5. This assigns 1 to I. I don't want that line printed out either, so I'll put a semicolon. Removing the semicolons is handy to get stuff printed out while you're debugging the program that you've written, the function, in order to find out what the mistakes are in it. Okay, then it gets to this while statement, and it says while I is less than n. If the value of I, which I just said was 1, is less than n, which in my example is 5, then what it's going to do is display I, so print it to the screen, and then it's going to bump up I by 1. The assignment statement is not an actual, the equal sign is an assignment operator rather than the algebraic equal sign. Obviously, the symbol I can't be equal to the I plus 1, but rather, what happens is the computer calculates what's on the right side and then stores the result in what's in the left. And it's okay if the thing that you're storing the result in actually appears in the expression, and in my case it does. So then it gets to the end of the while loop, and it goes right back here. That's why they call it a loop. It loops back up to here. At this point, I is equal to 2, so when it gets to here, it says, yep, I is still less than n, so it does what's inside here. Eventually, we're going to get up to I is equal to n, and I actually wanted to count up to n, so I wanted to print there. So I think I'll say while I is less than or equal to n. Then let's see what happens. When I becomes 5, it goes into the while loop. It says, yeah, 5 is less than or equal to 5, assuming n was 5. 5 is less than or equal to 5. So I'll go ahead and display it. So that displays the number 5. And then it bumps it up by 1. So I is equal to 6. Gets back to the while loop. The while loop says no. 6 is not less than or equal to 5, and so it does not do what's inside the while loop. Rather, it goes to the end and then does the next statement after that, which in our case is the end of the whole function, so it quits doing anything. So let's try saving that. I want to save it as countup2.m. Which it automatically starts naming it that for me. I save it, and then go to the command window. I think I'll go ahead and copy this. Go to the command window. I'm just going to paste that in with a Control V, and then change that. It said, suppose the user ran it with the value of 5 in there, and there it counts up to 5. So a pretty useless while loop, or I don't know, maybe it would come in handy for something, but you know, if I said count up to 19, it would count up to 19 or list all the numbers from 1 to 19. It's kind of not going to work very well. I didn't build in checks to well, let's see what happens if I try it with -1, for instance, or -5. You know, from 1 to -5, it's yeah, there's nothing from 1 up to -5. So actually, it does work there. If I go with if the user doesn't know what they're doing and they put a decimal point in there, I think that'll probably work. You know, 5.99, it would all go there. If I went with 6 point something, it would count up to there. So at any rate, that's how you use a while loop. I'm going to do one more little program here. I say go ahead and write that one and try running it. You will have written and run your second program. You find out, you know, how to deal with things if you type in, make little mistakes. I want to create a something that graphs. I'm going to go I'll have it have a list of values, which I'll store in a variable I'll call x, and have it make a graph of x versus x, x versus, well, x squared versus x, and x cubed versus x. So let's call it function. I'll call my return variable dummy. You cook up your own name for it for cases where you're not returning anything. Make graphs, and I'll say it's going to have no argument here. If there is no argument, you still have to have the parentheses there, and so the user doesn't supply anything. The user just types in make graphs, and it creates the graphs. So I'm going to go x equals linspace creates a set of values that yeah, this is kind of cool. When you start typing in the function, it tells you how it goes. So this just their notation here reminds me how it goes. It creates a set of values equally spaced from A up to B, and how many values it's going to have is n. So I'll go x equals linspace 0 to 100, and I'll try 101 values. Try enough values to make it so that the graph looks smooth. So I have created what's referred to as an array. X is an array of values. It's like a vector but instead of just 3 elements, this one it can have as many as you want. This one has 101 because I chose for it to have 101. So I'm actually going to save this at this point. This is a saving your work before you get all the way through. And if I type make graphs at this point, notice I left off the semicolon so it would print it, and I see x is equal to, and they call it column. No, I guess a row. It's one row of values with 101 columns, and they go from the values go from 0 up to 100. So in general, it's not okay to have all these values being printed out. So note if I put a semicolon in here and run the same function, I hit the up arrow to make it run, I get nothing printed out, so you can't even tell that it did anything. But that's where I want to be at this stage, and then write some more of the function. So I said we're going to graph x versus x. I'm going to go, the first thing I want to plot y1, and y1 is equal to x. So that actually assigns the 100 values that are stored in the array x to a new array that it creates at the same time called y1. And then y2 I'll call x squared, and y3 I'll call x cubed. So here's what I want to do. I want to create 3 graphs all on one page. It'll be y1 versus x, y2 versus x, and y3 versus x. One above the other, with y1 at the top, y3 at the bottom. So let's see how we go about that plot. I got to do something called subplot, and I want 3 rows and all in one column, and I want to start off in the very first spot. So if I recall correctly, this is number of rows, number of columns that you divide the page up into, that you're printing stuff, that you're plotting stuff on, and then the third argument is where you start. And I want to start in the very first. I got 3 regions and start in region 1. So if I don't recall correctly, then it doesn't turn out right, and I come back and fix it. I just have to debug. So then the graphing command is plot. Make sure you don't name a function plot, because the graphing command plot already exists. And you put it, I'm plotting y versus x, and y1 versus x first, but you do it in the reverse order, x, comma, y1. I'm going to put the semicolons here don't matter because they're not assignment statements. So if you just want to put semicolons on every single line, that's fine. It doesn't hurt anything. But if you leave it off on those, nothing's going to be printed anyway. And then I use the subplot command again. I'm going to copy and paste these 2 lines. So Control C, and then Control V, hit return, Control V. So I want to do 3-1 every time, but the second time I want to be in region 2, and the third time in region 3. And second time I want to plot y2, and the third time y3. And let's see how that's working, see if that works. So I go to the command window, type make graphs again. It's okay if you put open and close parentheses there. There's no argument, so it doesn't really matter. And I got some error. This is interesting. There's such a thing as matrix multiplication that MATLAB does, and in this assignment statement where I say y2 is equal to x squared, I want to do it element by element. So when you want to do something element by element, you put a dot in front of the operator. So I want to square it, or I want to raise it to the following power element by element. So I say x dot squared. So this part, the dot to the power, that's the operator, and it's an operator that says do it on an element by element basis. So I have an array, x is an array of values. Don't do your fancy multiplication, just multiply the first element of x times the first element of x, store that in the first element of y2, do the same thing for the second, etc. up through the 101st. So the dot operator is the element by element. And that's where you usually get some error that says matrix must be squared. So I'm going to do Control S there to save it. Go back to this window. I'll just hit the up arrow. I like the parentheses are optional. That makes no difference. And give it a little bit of time. And here are the graphs. This looks like a straight line from 0 to 100, so that looks good. And then the squared looks parabolic. 100 squared is 10,000, and this does go up to 10,000, so that looks good. Then 100 cubed, that's 1 times 10 to the 2 cubed, is going to be 1 times 10 to the 6. And it goes up to 10 times 10 to the 5th, which is 1 times 10 to the 6, so that looks good as well. So I've created those graphs. We have to, when you actually do your MATLAB projects, you have to title the graph and the axes. So I'm going to see if I can remember title. I'm going to try just title. There it goes. And then a string has to be in single quotes. It looks like it's helping me out there, so I'll get it all ready for what I have to stick in there. And for the first one, I'm going to call it x versus x, and see how that's working out for me. So that's the nice thing about programming is you can make mistakes all over the place. You just try it and see if it's working, and if it's not, fix it. Figure out how to fix it. So I'll do a Control S to save it, and try and make graphs again. And this time, the first one has that title, x versus x. So that's working out for me. And then I think the other commands are x label and y label. So I'm going to try that. So I got to label the axes as well. X label so I think based on the colors things are turning. This looks like it's working out for me. And along the x-axis, I'm going to plot x, and I'll tell the user that it's in meters. Use square brackets so it doesn't look like it's supposed to be a function of something called m. So the name of what's being plotted along that axis, and then the units. And I'm going to gamble that I got that right, and say for the other axis it's going to be y label. And in this case, it is, I'll call it X in meters. Let's see how that looks. Plotting X versus X there, so it's an okay name for it. So didn't like something about that. I got apparently got the name wrong. So let's try debugging it. Error in. I got X label instead of just X label. Let's see if fixing that spelling error takes care of things for me. And that's a graph, I think. So let's try running it again. Alright, didn't seem to come up with an error that time. And sure enough, we got X in meters versus X in meters. We don't have to do them all here, but I'll try one more. Let's copy all this stuff down to, so you make the graph first and then title it, and title the axes. So in this case it would be X squared in meters squared, and I'm plotting X squared versus X, so X squared. So let's try that. Control S, run it. Check this out. This is kind of cool. The title command automatically puts, when I wrote it as X caret 2, it interprets that as X squared and makes it look like X squared the way we would write it by hand. So X squared in meters squared versus X. So one would have to do the same thing for the last one. So I think that pretty much takes care of everything. You know, write those three little programs. As far as the actual programming, you have to do documentation too. Yeah, let me show you that some documentation. I say for every single one, you have to say what the function does. So I'll call it make graphs. So for just typing in comments, this is just for the people that are using your program and maybe they want to modify it to make it do something similar but different. You should tell them things in comments. Tell them things about the code. Make graphs. Creates a graph of X versus X, graph of X squared versus X, and a graph of X cubed versus X, where X runs from 0 to 100 and is considered to have units and has units of meters. So I think I hit a key with the palm of my hand by mistake. That's why things went haywire there. But make graphs creates a graph. I'm supposed to say who wrote it. So function make graphs by Jeffrey Schnick. In the documentation, you're supposed to say, tell the reader what the arguments are, and this one takes no arguments, so it has arguments. What would appear in the parentheses here are input variables, the values that the user inputs to the program, gives to the program when they go to use it, and then whatever it returns, what it sticks in dummy, is an output variable, and you can see this one has no input variables and no output variables. Even in that case, you have to tell the reader make graphs has no input variables and no output variables. And down here at the end, percent attribution, no outside resources are used in the writing of this function. So if you were to actually write this one up and you decided, I want to try to document it properly, you couldn't write that. You would say, I use Professor Schnick's Getting Started with MATLAB video to help me write this code, to help me write this function. So that tells you a little bit about the documentation. Sometimes you accidentally hit some key that messes things up. I think I want a little space in there. There's a Control S. So I should run it again to make sure, even though all I did was type in documentation, so it shouldn't make any changes at all, but run it again to make sure it's still working. And it's working as it was before. I never did finish it up, so I haven't got what's being plotted here labeled. I think the only other thing that I can remember that could come up in your project number 1 is, let's see if these guys are still here. I believe it was, yeah, this one. So I wanted to do this while I was less than or equal to n. In your code, in the project, I used a while loop, and it had to be while such and such a value was between two values. And so for me, it was while it would be analogous. I don't think I used the variable while, but it would be analogous to while I is greater than or equal to 0, for instance, and the other condition is also met. The way you do that is to type in the double ampersand, and that means and. Just to make sure that I got that right, I'm going to call this dn, and my function is going to be a little bit different. I is equal to I plus dn. So the user would have to type in two things here. By the way, this one would have input variables but no output variable. Let me see if I did what I meant. I'm going to just try running that. So this I wanted to now, and it's not really count up to. It might not be appropriate if dn is negative, but add dn to start with 1 and keep adding dn, and I'm going to go while it's greater than or equal to negative n, and it's less than or equal to n. So it'll count down if dn is negative, because I'll keep adding a negative value, and it'll count up if dn is positive. Let's see if that works. Control S, and it's count up to is the program that I'm trying to run. Count up to, and I'm going to go 5, 1, so it should work just as it did before. And then I go 5, minus 1, 5, negative 1, and it actually counts down. So it was always starting at 1, counts down from there, and it is 5 once it gets down to minus 5, it stops. So so it works both ways. So that's not, just to show you how to use that ampersand. It's not like I'm trying to write some useful program there. So I'm going to call that an end on how to use MATLAB. Usually when I quit it, I type in exit. I meant to minimize that window, and I killed it instead, but that's okay. We're at the end of what I wanted to talk about anyway. So I call that a wrap on getting started with MATLAB.